In the previous video, zone-based policy firewall discussion, I talked about the theory and the functioning of a zone-based policy firewall and how traffic flows between them, how to define it, and then I left us with the configuration steps, but we hadn't actually configured anything. We just went through the understanding of a zone-based policy firewall. Now in this video, I want to go ahead and let's work with the topology and configure a zone-based policy firewall. So let's start off where I left off in the last video, which was just the configuration steps. So what are the steps that we need to take and what are the commands in order to configure a zone-based policy firewall? So the first thing is we need to create our zones. And even before creating our zones, we need to sit down, look at our network and have a discussion about, okay, what are our zones going to be? Are we going to have 2 zones? Are we going to have 3 zones? Are we going to have 4 zones? How many zones are we going to have? And how many interfaces are going to be in those zones and what interfaces will be in those zones. And then what kind of traffic are we going to look at? Are we going to match ACLs? Are we going to match protocols? Are we going to match ACLs and protocols? So that's a discussion come prior to configuration, right? And once you've had that discussion and you look at your topology and say, okay, now the first thing I've got to do is create my zones, and I'll do that using the zone security command. And then I've got to identify the traffic. So the traffic I decided I was going to do something with, I'll do that with my class map command. We have to do something with the traffic, so we identify it, then we have to act on it. You'll do that with the policy map command. You'll create the zone pair, which is the traffic flow for the zones, how the traffic is going to flow amongst the zones. And you can have multiple zone pairs. And then lastly, you'll add interfaces to our zone. So a zone is really just a collection of interfaces with similar functions. So we create our zones. We create the rules of each zone, right, based upon identifying our traffic and acting on it. We create the flow, or how things are going to flow between zones, and we add interfaces to those zones. So let's go ahead and look at the topology we're going to be working with. So here's a pretty simplistic generic topology that I have. What I actually have going on is a couple PCs, one PC here, one PC here. These two are actually routers. Let's just call them nodes. They're not routing anything. I've shut off IP routing on them. What that allows me to do is these guys will just act as hosts without having to have extra PCs if I didn't have them on my network, because I have these actually pre-configured to set up to other things. But so for the purpose of this is all you have to worry about. This is our topology. I'm going to start by going from PC1 and pinging all of our different nodes to verify that yes, in fact, we do have full connectivity. Actually, what I think I'll do is I'll start from PC2, because he will be the outside. When I go ahead and configure our firewall, he's going to be the outside. Right? And so by default, when I configure my firewall, what should happen is that stuff shouldn't be able to originate from the outside to the inside. And I'll explain that in just a second. But I think to verify first that we have full connectivity, I'll go ahead and go into PC2, and I will ping 10.10.3.10, 10.10.2.10, 192.168.3.10. All right, so now I have the command prompt up for PC2. Let's verify we have connectivity. What do we say? 192.168.3.10, which would be the inside LAN PC on our topology. 10.2.10, which is that node on the inside of branch 1 on our topology. There we go. Just dropped 1. He's okay. And 3.10. So we're going outside to what will be our inside, or basically what currently is our inside branch networks. And we can get to all of those areas. I'm going to do one more thing. I think I'm going to go, let's go PC1, because I want to show you the differences between when things are part of a zone, when interfaces are part of a zone and when they're not. So I'm going to go flip over to PC1, and we're going to ping to the loop, or the 10.10.2.10 and the 10.10.3.10, and then we'll go from 10.10.2.10 to 10.10.3.10. Hopefully all these numbers aren't getting really confusing. So now I pulled up the PC inside of branch. He's the 192.168.3.10, so he's going to ping 10.10.2.10. We're successful there. We hit the up arrow, change the 2 to a 3. And we're successful there. Okay, so we're good on this part. We have connectivity. We want to check that first because it doesn't do me much good to show you the configuration steps of a firewall without you actually seeing that it will block some things and it will allow some things when we're done. All right, so here's what we're going to do with our firewall. Here's what we're going to configure. We're going to configure 2 zones. This will be my inside zone. And this is going to be my outside zone. And we are going to inspect ping traffic coming from the inside to the outside, which means that sorry, my firewall will keep track of my ping, and if it originates from the inside, the response will be able to come back. If a ping were to originate from the outside trying to come in, the firewall won't allow it in. But when I tell my firewall to inspect ICMP, it's going to say, okay, I'm going to keep track of that. And as long as it originates from the inside zone, going to the outside zone will allow a response. I'm not going to put either one of these guys in a zone, just to demonstrate what happens. So you configure your firewall on branch 1, and maybe in your head you're thinking, well, all these interfaces are on branch 1. These are all the inside of my network. They should all be allowed out, right, and be able to get responses back. But unless they're part of a zone, that's not going to happen unless you explicitly configure them as part of a zone. I'm going to get rid of some of this. Let's get rid of our ink here. There we go. All right, so again, I'm going to create an inside. You know, I could have just as easily stuck another zone, or could have made one of these guys a different zone. Maybe the DMZ, maybe I've got a web server here, and I want the outside to be able to get to the web server, but I wouldn't want that to then be able to come in here. So I would create my demilitarized zone. In this demonstration, I'm just doing an inside and an outside zone, and then we're going to demonstrate and show, okay, how traffic originates in to out will work, but out to in won't work, and how these guys not being part of a zone, the traffic will be dropped, because I can't originate, or I can't set policy on interfaces that aren't part of a zone. All right, so we'll pull up, we're going to configure that all on branch 1. Our 2 zones. And for the first part, we're just going to inspect our ping traffic. So we're just going to allow ping traffic as long as it originates from the inside. So first we got to configure our zones. Zone security, and give it a name. Notice I can't tab complete. So even though we feel as though it's common nomenclature to call things inside and outside when you're talking about a firewall, the iOS doesn't just have that in there. You have to specify it. I'm going to specify an inside, and I could provide a description here, but I'm not going to. Zone security. We'll create our outside zones. Now I have my 2 zones. Now I've got to decide, okay, what kind of traffic? So I'm going to go ahead and identify my traffic with my class map. I do type inspect because class maps are used for a lot of things. Inspect identifies that this class map is going to be used for a firewall. If I hit a question mark here, you can see some of our options. We want to configure a firewall class map. So we're going to use the keyword inspect. And we can match all or match any. So if I have multiple parameters, I can match on multiple protocols. I can match on access control lists and protocols. And I can match on either all of those parameters, or if any of those parameters match, I can do something with them, right? So here I'm going to do a match any. Means if any of the parameters I list match, I'm going to do something with it or act on that traffic in some way in the policy map. And give it a name. Class map 1. And then we have to match something. I'm going to at first not match something because I want to demonstrate to you what happens when you don't. Let's say I forget, or I don't match any traffic. So what happens? So I create my class map, okay, and then I want to act on the traffic with our policy map. Policy map type inspect, give it a name. Okay, I want to link my class map to that, so we go class type, inspect, class map 1. I'm just calling my class map from up here down in my policy map. And then I want to inspect the traffic. Now what I wanted you to notice, and I could go through and ping and we could verify this, but I think getting the error message or the notification message is good enough. No specific protocol or access group configured in class map 1, which is what I called here. For inspection, all packets will be dropped. If in your class map you forget to match any sort of traffic, whether it be ACL or protocol or whatever, by default then now when I go ahead and finish my firewall configuration, all traffic will be dropped. So we don't want that to happen. So let's go back into our class map. Sorry. I'm just going to copy and paste it up here so I don't have to retype it. And we want to match ICMP. Oops, match protocol. And we can go ahead and exit out of there. Now we want to create our zone pair. Call a name in to out. Okay, I'm just naming it. It's a zone pair security. And then the pair, what I want to name the pair, I'm just going to name it in-out for in to out. The source will be inside. The destination is outside. Now I've got to apply it. Service policy type. Oh, gotta spell policy right. Inspect. And then we call our policy map name, which is policy map 1. Hopefully I don't have any typos. Now we pretty much got our firewall configured. Now all we have to do is add interfaces to our zones. We said our gig 01 is the one facing the ISP, so he's going to be a member of zone outside. Zone member, security outside. And our inside is gig 02. He's facing our internal LAN on our branch network, or on our branch router here. So he's zone member. Inside. That's it. We've created our zones. We've identified the traffic we want to match as ICMP. I've also just shown you that if you don't match any traffic, everything will be dropped. We've created our zone pair, or we've created our policy map to act on the traffic. We've created our zone pair, and we've added interfaces to our zones. Notice I didn't add either of our nodes in the 1010 networks to any zone. They're not part of any zone at this point. So let's bring up our PC. Let's bring first up the thing that shouldn't work for us, right? So let's go through and let's go to PC 2. All right, so now we're in our PC 2. I'll show you real quick the address. This is the address on the inside, or not, I shouldn't call it the inside, connected to ISP. So let's call it the internet. There's some out in the internet. If a firewall is working correctly, when we ping from here into our branch router or our branch office, it should not work. So we'll go ahead. And remember, before we started a build of our firewall, we pinged all of these addresses from this PC and from the other PC. And they all worked. So we'll hit a Control-C here because we know that's not going to work. Now let's go ahead and let's ping the one of the other nodes on the inside. Go 3.10. Okay, so our firewall's working good there. It's stopping our ICMP traffic that originates from the outside. Now let's go ahead and move over to PC1 and verify that, in fact, if the traffic originates on the inside, that the flow will be kept track of and our response will be able to come back. So I brought the window over, our command prompt over for our PC on the inside of branch and verify that his address is 3.10, so we are on the right one. Now we're going to originate ping traffic from him to the PC we have on the inside of the internet or inside the ISP. (192.168.2.10), If I originate the traffic, it should work. Oh, hold on a second. Sorry, I just want to move the window so you can see a little better. So we originated the ping traffic. Let's also ping the loopback. There's also a loopback over in the ISP. Okay, so inside to outside works fine. Now let's go over to our branch router and look at our session. So we can also verify by doing a show policy type inspect. So our show commands, right? We'll look at the zone, this particular zone pair that we would have matched on, in to out, and let's look at its sessions. Oh, what did I miss? Oh, forgot the map command. Show, or the map keyword type. This is definitely where tab completion is wonderful, but I try not to do that to you guys too often, just so you can see the whole thing in one part. So I want to verify the sessions, look at the session information for our zone pair in to out. Okay, now if I do this again, oh, show, and that time I forgot the, all right, hold on here, what am I doing? Somehow, oh, because target, I could use target. I was like, why is it not tab completing at type? Inspect. Let's try to finish this up for you again. I just didn't want to keep having typos and then just get more confusing. Zone pair into out. Now let's see if we can look at our sessions. There we go. And we can see that we're using class map 1. That class map matches any. We had 4 packets match. So just some information. The default, so if the packets don't match this protocol, the default is to drop. So if I don't match, then I'm going to drop. Okay, let's do a couple more things. Let's go back to PC1. So I go back to PC1, and I move the command prompt up. Whoop, sorry. All right. Now let's ping from our inside zone to our 2 nodes that aren't even part of a zone. And this is actually exactly what I wanted you to see here. So we can't create policy, or we can't inflict policy upon interfaces or upon areas, zone, or upon lands or whatever that aren't part of a zone. So I didn't put those 2 nodes. If I go back, I didn't put these guys here in any zone. And since they're not part of any sort of zone, then I can't inflict any policy on them, and the default will then be to drop. Now, these guys should be able to ping between each other, but they cannot, nothing can ping to them, right? And they can't ping to through any zone, because they're not assigned to a zone, which means they're not part of a zone flow, or zone pair, which means they're not part of a flow. And I can't inflict policy upon them. So just something to keep in mind, to say, okay, when you're configuring your iOS firewall, make sure you've included all the interfaces that you want to include in the zones. Maybe you only want these 2 LANs to communicate with each other. You know, maybe they're segmented off a certain way, whatever, but just be aware of that rule or that caveat. One more thing I want to do is I want to show you that you can add protocols to your class map, and they'll then go ahead and be added to the policy map and your firewall as an option. So let's go back to PC1, I think. Yeah, let's go back to PC1. In PC1, I lied. Let's go back to our picture here. We're going to deal with this guy here. PC1 is going to go ahead and ping to him, and then we're going to try to telnet to this guy. Now let's go back to PC1. Okay. So we ping 10.10.1.1, no problem, right? Inside zone to outside zone, we can get there. what we should notice here now is that we can't telnet because it's not part of our firewall rules. Okay, when we inspect, it keeps track of the flow originated from, because that's what I've defined here. You could define a lot of things, but it keeps track of the flow and the protocol, the policy set on the in to out zone pair. So I set a policy that says if ping or ICMP originates from the inside, it can go to the outside. But then because there's no other traffic I said to act on, the next default is to drop everything else. So this telnet is not ICMP, so what is it going to do? Drop it, even though it originated from the inside. So let's go ahead and let's go back and let's add telnet, verify that it works the way our firewall should work, and then let's wrap this one up. I hate to go more than 20 minutes on a video on you guys. So we're going to bring branch up, and we're going to go into our class map. Sorry, I'm always having that in the way, aren't I? And it was called class map 1. And now we want to also match, we still have an any, so we can match either, right? Either or. So if ICMP or telnet originates from the inside, goes to the outside, protocol, I almost forgot the keyword protocol again. It should work. So now we're going to say, okay, pay attention to telnet. If it originates from the inside, okay. We shouldn't have to do anything else here. And it worked right away this time. I don't remember what I even did as a password. Okay, so now we're into that router. So now we've verified. We first did, okay, inspect ICMP, which means, okay, if it originates from the inside, allow it to come back. I showed you that other traffic then couldn't originate from the inside and be allowed to come back. So I couldn't telnet from the inside. It wasn't successful. We added telnet as a protocol within our firewall, within our class map, and now we can do it okay. So I think that's it. I think we covered everything. Thanks.